Hey there, we are working on, this is still Module 3, Lesson 15, you're locating ordered pairs on the coordinate plane. So remember your X and your Y axis. And now we've got those four regions. When we've got the X and the Y axis, they're called quadrants. And we will note those with Roman numerals. I'm trying to figure out what that is on my deal. Okay, so the opening exercise here says extending the axes beyond 0. This must be a point. The point below represents 0 on the number line. So if I had that, whoops, let me grab my, if I had the number line, and that's 0, draw a number line to the right starting at 0, okay? And you know what? I could use a straight edge. That would be good if I had a ruler. To the right, I did that. And then I'm just trying to see what else they're going to ask me to do. I think, so we've got the x-axis. This is my x-axis. And then, I don't know if I need to, but, so this would be my y, right? My x and my y. And so it is a 0, 0 with those two intersecting. So I don't know if I was supposed to do that, but anyway, that's okay. And again, like if I were putting in, I'm going to space these out a little bit because, so if this is 1, 2, 3, 4, right? And then if I'm going up, 1, 2, 3. But then as soon as I start going down, then this is -1, -2, -3, like below sea level. I think about going underwater. And then if I go this direction, like when you did the vertical number lines, this is -1, -2, -3, -4. So we also talk about, and I don't know if I'm going ahead, but this is quadrant. All of these are quadrant. This is quadrant 1, and that's positive, positive, right? And then we have quadrant 2. And this is negative, positive, negative, positive. Then we have quadrant 3. Okay, and this is negative, negative as far as the coordinates. And this is quadrant 4. Remember? We've got the Roman numeral 5 and then take away 1. And this goes positive and then down below negative. Okay, so those are our 4 quadrants that we're dealing with. So then example 2 says, all points on the coordinate plane are described with a reference to the origin. That's 0, 0. What is the origin and what are its coordinates? Well, I think we just talked about that. It's where the x and y axes intersect, right? And at that point, it's a 0, 0. That's the ordered pair. To describe locations of points in the coordinate plane, we used ordered pairs of numbers. Order is important, so the coordinate plane. So on the coordinate plane, we use the form x, whatever the number is on the x-axis, and then the y-axis. The first coordinate represents the point's location from 0 on the x-axis. Second coordinate represents the point's location from 0 on the y-axis. Okay, that wasn't so bad. Then this one says, use the coordinate plane below to answer parts A through C. Okay, graph at least 5 points on the x-axis and label their coordinates. So you can do whatever you want, but I have to, let me think, do I have to label them too? I think this says on the x, graph at least 5 points on, so here's my X, here's my Y. So I'm first going to just come in here and there's 1, 2, 3, 4. It said at least 5. There's 5. Okay. So then it says that label their coordinates. So this is a 1, 2, 3, 0, 3, 0. This is 4, 5, 6, 7, 0. And then this is 10. I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, I had to recount because it's like so small. Okay, so then I got to go this way. 1, 2, 3, negative 4, 0. 5, 6, 7, 8, negative 8, 0. Okay, so I got my 5 labeled. Then, what do the coordinates of your points have in common? They have the y coordinate of 0 in all of them. What must be true about any point that lies on the x-axis? Well, then the y coordinate is 0. So then it says, use the coordinate plane to answer. Okay, graph at least on the y-axis. So I'm going to change this to be a different one. So I'm going to go 1, 2, 3, 4, 5, right? What do the, oh, I have to label them now. So 0, 1, 2, 3, 4, 0, 4, 5, 6, 7, so 0, 7. Now I'm going to go 0, negative 1, and then 1, 2, 3, 4, 0, negative 4, and then 4, 5, 6, 7, 0, negative 7. I hope you can read those. Okay. What do the coordinates have in common? The x-coordinate is 0. What must be true about any point that lies on the y-axis? Well, the x-coordinate is going to be 0. It can be above or below that x-axis, but it is going to be, the first coordinate will be 0. If the origin is the only point with 0 for both coordinates, what must be true about that point of origin? Well, the origin's the only point that is both the x and the y axis, right? Did we mark that? Not really. Right there. So it is the only point on both the x and y axis. Okay. So look next and see what we have. Oh, quadrants of the coordinate plane. So we've got the 4 there. And the x and the y, I'm just going to label, here's our x, here's our y right here. Or maybe I'm going to go over here. Let's see. So we had prefix quad means 4. That's true. The region on the top of the coordinate plane. So this quadrant 1 is what you probably dealt with last year, quadrant 1, which is a positive. And then, because we didn't learn about negative numbers yet or not, you didn't focus on that. And then it goes counterclockwise, which we just went over. So this is quadrant 2. This is quadrant 3. And this is quadrant 4. That is the positive, This is the negative positive. This is the negative negative. And this is the positive negative. So that lets us know if I'm looking at a set of numbers ordered pair, I know which quadrant I'm going to be looking at when I start looking at the signs. So then on 4 through 6, locate and label each point described by the ordered pairs. Indicate which of the quadrants the points lie on. So first I have to locate it. 1, 2, 3, 4, 5, 6, 7, 7, 2. And so that is in quadrant 1. And I think, I can put quadrant 1, I can write it, or I can put Roman numeral. Then 3, 1, 2, 3, 4, negative 4. So that is in quadrant 4. 1, negative 1, 2, 3, 4, 5, and that is quadrant 4 as well. Okay, then what about negative 3, 1, 2, 3, and I'm going to go up 1, 2, 3, 4, 5, 8, if I counted that right. That is in quadrant, so this was 1, here's quadrant 2. So quadrant 2. Then we have negative 2 and negative 1. Quadrant 3. We have not had that yet. There we go. Okay, and on, write the coordinates of at least one other point in each of the 4 quadrants. So in quadrant 1, and I'm just looking at my, let's see, I could go, I don't know if it's going to be the same, but they're both going to be positive. So I could have a 2, 3. If I were going to be in, so if I sketch this out up, so I'm over here. Quadrant 2, I'm going to go a negative 2, and I'm going to go a positive 3. I'm just going to here, so I'm over negative 2, up 3. Then if I go quadrant 3, I'm going to go negative, and I'm going to go negative. So negative 2, negative 3. And then quadrant 4 is going to be a positive, positive 2, negative 3, positive 2, negative 3. I'd be down here. You can use any ordered pair. They just need to be positive, positive, negative, positive, negative, 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 or positive, negative for the different quadrants. Any similarities in the points within each quadrant, just at the signage, right? The x-coordinate, if I'm looking at, let's see, I'm trying to see the ordered pair in quadrant 1 are going to have all positive values. And in quadrant 2, it's going to be both, let's see, in quadrant 2, it's going to be a negative positive. And then I'm trying to think quadrant 1 is positive, positive. Quadrant 3 is negative, negative, right? This is 3. And so then quadrant 2 is negative, positive. Quadrant 4, I left out my A, is positive, negative. So they just kind of reverse. So 1 and 3 are here, and then 2 and 4 are this way. Okay. So let's see, I think that covers our lesson, and then you're ready to work on your problem set and your exit ticket. Yeehaw.